Okay, good morning, everybody. Welcome back. Hope you had a good holiday weekend. And we're going to be continuing with the last new review part for iOS today, and we'll be wrapping this up on Thursday. Obviously, we're heading towards assignment 5, which is the same, very similar to assignment 2. Um, But before we get into that, obviously, usual announcements. Obviously, assignment 5, which we'll be looking at the end of the session, first half of this morning, due on Friday. And obviously, assignment 6 comes out on Thursday, usual overlapping thing. Assignment 6 being the equivalent of assignment 3, and has, what's the word? It would be the network connected one, which assignment 5 is just using data that's stored in memory. Okay, and we're just going to have a quiz today. Um, I've only had one email about this, but the announcement on Canvas yesterday, if your assignment 3 solution didn't work in the autograder, slightly less than half did. So the majority of you had a assignment 3 that didn't work. Request by email. There's a posting in Canvas from yesterday, letting you know what the title of the email needs to be, and we'll actually run through that manually. So one of the things to be keeping track of as we move between the 3 different ways of developing applications for mobile devices is the ease or otherwise of having reproducible tests. You notice in Android, although we gathered code coverage when we were doing raw Kotlin, in Android we didn't, because Android Studio and the build environment doesn't actually support that out of the box. You need to include some fairly convoluted third-party products to do that. Whereas Xcode does, supports that natively. It's now a default. It used to be something you had to switch on, but now it's the default. It's part of the development process. And we'll see once we get into cross-platform with React Native what the equivalent is there. So if you come away with a lot of information from the class, but if you come away with a good understanding of the differences in between how you test and the ease or otherwise of testing on the 3 platforms, that's a good, very powerful piece of information to have. And it's an understanding that not many developers have. They tend to know their one environment and ignore the others. Okay, so if you haven't requested, if you got a 0 which you weren't expecting, and if you haven't requested it, pop me in the email as soon as you can, and I'll make sure that gets done before the end of the session. Well, there's a question there on chat. This is what we're trying to find out. Just very quickly looking at some of the logs, there are quite a lot of solutions that were just failing to log in. So that suggests some kind of a what's the word? A challenge internally within the code. But each one will need to be investigated manually. There doesn't appear to be one size fits all solution to that. Obviously, the thing we have to bear in mind is that not quite half the solutions did work quite happily. So I'll have to find out what's going on there. But send me the email and I'll add it onto the list of things for me to actually look at one at a time manually. Yeah, so there's a question there. It was just on the direct one about assignment 2. Same issue there. If it didn't bill correctly on the initial submission and it still hasn't got a grade, it means it's not building correctly now either. So that has to be done manually. So that's kind of it's a very slow process. So. Okay, all right. So we're going to dive straight in with the Android quiz. So a couple of things you need to do is one, you need to turn your cameras on. Liam, I think you joined without one. So if you want to rejoin on a device that's got a camera, that would be good. And whilst you're doing that, I'll just give you some, I'll make it available in Canvas momentarily. So 2 types of question. The classic multiple choice, so where there's one answer. And obviously that's indicated it has a little, the round radio button. And then there's a multiple select type of question where there is 1, 2, or 3, basically, 1 to n correct answers. And they're obviously the nasty ones, because if you say there were 3 correct answers and you select 2 correct ones and 1 wrong one, the one wrong one um, it cancels out one of the right answers. So unless you're really, really sure about an answer, it's better to sort of leave it unchecked, because that tends to have a negative effect. There aren't too many of those. Most of them are actually just a multiple choice, regular multiple choice. It's a speed run. You have 15 minutes to do 30 questions. So it's really, with one of the first answer that you seems right is probably the right answer. So let's get that clicked and moved on. You can't go back. So once you answered it, that's that question done. They're randomly selected from a large question base, and the order is random as well. So you may find a question on I don't know, RESTful APIs early on, and then another one later on, so they're not grouped because they're randomized in terms of where they pop in. Okay, right. Let me just stop sharing the slides. We're still waiting for a few people to join in. Yeah, so those of you, so Liam, you'll need to rejoin, so you have a camera device, and then there's another 3 people who are not quite switched on yet. So give Liam a minute to get in there. And what time are we at? -7. Let's make it start at 9. Hmm. Yeah, it's going to finish here. If you get ready to refresh your canvas, you should see that in the quizzes category on your assignment. Someone give me a thumbs up. Make sure you can actually see it. Okay, good. Alrighty, so that will open automatically. Usual thing. You've done many of these before. That'll open automatically at 9:10, and it's actually open for 17 minutes, but you have 15 minutes to finish it. So anybody who's a little slow on the button, you won't actually run out. So he's reconnecting with his video. Okay, and then once we're actually done with the quiz, I'll put up we'll just sort of have a little bit of a break until, when did I say we're gonna have a break until 9:30, and then we'll dive straight back in and carry on with the iOS stuff. Okay. Few more minutes. That's a good question. Yeah, so there's 2 kinds of question. Again, multiple choice where there's one answer, and multiple select where there's 1 to n answers. Yeah, it's open book. I want to see it here. It's the but it's a speed run, so it's really testing what you can recall. I was saying if an answer looks right, it probably is. Don't overthink it. Okay, so I'm going to go on mute, and it should open momentarily. All right. Everyone's done. Some very nice looking grades there. Well done. 4 minutes. We'll be back at 9:30, and we'll carry on with the iOS stuff. I'll see you in a couple of minutes. Hmm. Um, hmm. Just I'm just going to put into Google Drive an example that well, I've been looking at a couple of examples this morning, but I've just put one in there that's O9 data classes.zip. If you want to grab hold of that, whilst we're just doing the preamble at the beginning, and then we'll be ready to start looking at that in a moment. Okay, so obviously we've had the quiz. Good. We'll just have a bit of a little bit of extra information about some things that we need to do to move on through the assignment 5 and 6. And we'll look at the Swift way of doing it. So as I mentioned this earlier, but as we go through the class, the lectures basically get shorter because we're no longer introducing concepts. We are looking at a specific technology's way of handling that concept. So we looked at serialization and how to get hold of raw data. Some of you might have got a question on raw data in the quiz. So there must be an equivalent of that in iOS development. So we actually look at how what that is, how it works. But the concept is something we're rolling forward from Android. And when we get into cross-platform development, we're seeing everything for the third time. So that's very, very quick. to actually get through. And then a little bit more information about Swift UI. So we've used it already in assignment 4, but in a very simple form. As we want to get more sophisticated apps with more interesting visual components and the ability to navigate, as we did in assignment 2 and 3 in Android, we need to know a little bit more about SwiftUI and how it actually works to do exactly the same things as we've done before, but this is the iOS specific way of doing it, and even more specific, it's the SwiftUI way of doing it for iOS. So we're looking at some examples, and then at the end of this one, we'll be looking at assignment 5. And then that will be it for today, because I'm going to use the extra time to just try and find out what went wrong with your assignment 3s. Okay, so the first bit, so application resources and serialization. So in Android, we had them in the raw resources folder. Excuse me. And in order to access a raw resource, in our case, JSON files full of ball clubs or Slack style workspaces, they had to be in that particular location. Whereas in Swift and iOS development, they can actually be anywhere you like. And what the build environment for iOS does is it just goes looking for them. And in your own code, you access it through this global singleton, so a single instance of a particular class called the bundle, and we can read them in by name just from the bundle, and the bundle will go and find them. So if we say there is a file called ballclubs.json, it will actually go and find it for us wherever it actually lives. So if we've got ballclubs.json somewhere in our source hierarchy, and it's traditional in iOS development to keep the data close to, typically in the same folder as the classes that are actually going to use that data, which is quite different to Android, where the raw data is a long way away structurally in the source code tree from the code that actually uses it. So let's say we have ballclubs.json lying around somewhere, and we'll see this in the second example we look at this morning. And we can find it via the bundle, and we basically just say we're looking for a resource called ball clubs. So notice that the .json bit is missing, of type JSON. So we could actually have called it ballclubs.txt. It would just go looking for a file that contains JSON. But the thing that we get back, this bundle path, is not yet the textual representation of that JSON file on disk. We actually need to get hold of the data. So in Swift, even if you have a string, excuse me, the thing that we get returned from it is data. It's binary data, rather than us saying it is a string. It's data that happens to be a string. So here we actually want to get hold of a stringified data binary version of whatever is in that resource, so in that bundle path. So we go ahead and get the data from the bundle path, and we are telling it that it's UTF-8, so that's the character set that we know or expect or hope the ballclubs.json is in. It should be. So JSON should always be in UTF-8. But the thing that we get back, the data object, is it's a string of bytes. So we need to convert it into some kind of a type. So the JSON data that comes back, we've said we want to try and make this into a string. If we can't, that's going to throw an error we should actually have to handle. But because the ballclubs.json is a bundled resource, we know in advance whether or not it's going to be correctly formatted. When we test the app, we'll know whether or not it's in the right format. If it was coming across the network, obviously we'll get to in assignment 6. We don't necessarily trust it, but we've definitely got to try. We're trying to turn this raw data, this sequence of bytes, into a string in UTF-8 format. It might be a sequence of bytes that is a string, but in the wrong character set, in which case that try would throw an exception. Okay, so now we've got the raw data of the JSON, but we're not yet, we don't yet have Kotlin, sorry, I beg your pardon, wrong system, Swift objects that we can manipulate within our code. And to do that, we need to do serialization. So in Android, we have the at serializable declaration on a data class. In Swift, we have a struct because it's the simplest data way of holding data. So we don't need a class. That's too gone too big, too large, and that struct is all we need. And we talked about protocols on Thursday, so it needs to be decodable. So the ball club struct conforms to the decodable protocol. Excuse me. It's also identifiable, which means it has to have the ID attribute. Excuse me. But for instance, it has an array of stadiums. So all the nested structures must also be decodable. Now, so the stadium struct, the stadium type, is not identifiable, doesn't need to be. I mean, we could decide that, but it doesn't have to be. But the stadium needs to be decodable so that whatever struct it is included as part of can be decodable. And the compiler will tell you if you're trying to have a nested structure that is not decodable. So here, obviously, a ball club needs to have an ID. It needs to have a name. Boston Red Sox. It needs to have a code, BOS, and it needs to have 0 or more stadiums. A stadium has to have a name. It may or may not have a location. This is optional. It may or may not have a capacity. It may or may not have a year, so a year where the stadium was built. So we've got a bunch of JSON, which is we've now got from the input stream into a string, and we want to convert that into our Swift objects. Excuse me. So we're using the JSON decoder, which is part of Swift, and we're saying decode as opposed to create new JSON. And we're getting it from the JSON data. Excuse me. And this parameter here, we're telling the JSON decoder what we believe is in this JSON string. And what we believe is in it is an array, square brackets, of ball clubs. And the dot self is introspection. And that allows the JSON decoder to basically look at the array of ball clubs type and find out what is in there. So from this little piece of syntax here, the JSON decoder can say, okay, it's an array, I get that, and it's an array of ball clubs. So what does a ball club look like? Okay, it looks like this. Okay, I see stadiums. What does a stadium look like? Okay, I see this, and I can see that these are optional. So now I'm good to go. As I start decoding the string, the JSON data, if anything in there is not a ball club, or it's not an array, then again, this try will throw an exception because we're saying we're trying to decode an array of ball clubs, but what we found was something else. Something was not an array of ball clubs. Assuming everything goes okay, which it should do because this is internal data, we end up with clubs, which will be an array of ball clubs. So we'll come back to this a little bit. We'll look at the second example. So let's actually go and have a look at, let me just bring that up for a minute. Actually, we can look in the data classes example now. I'll just share this over here so we can take a look. Yeah, we'll do it this way. Oops. Okay. So we've got our ball clubs, which is JSON. Obviously, nice long big JSON. So it's an array. You can see the array at the top. And each one of the ball clubs within it conforms to the ball club definition. So it's decodable. It has a stadium, an array of stadiums, which they are themselves decodable. So here, the Baltimore Orioles have a single stadium listed. I'm not sure if any of them have more than one. Maybe not. That's a separate example. So they've all got one stadium, their main stadium. They could have had two, because every ball club has a regular season stadium and a spring training stadium, but all of these have one. So now we've defined everything. We've got the ball clubs themselves as JSON. We've said what a ball club is. We've said what a stadium is. So now we actually want to see that on the screen. And we start with the app. Basically, this is a very simple scene with a single window group with a ball clubs list, which is obviously here. And we'll let the preview do its job. So obviously we get a list of ball clubs. So how do we get that? Well, this is the ball clubs list, which is it conforms to the view. And we have some local state, which is an array of ball clubs, which we get from the JSON resource. Yeah, so this basically ball club is this class, and this is the function from JSON resource. Obviously, it does what we are seeing on the lecture slides. So we get hold of the name, in this case, ball clubs. So ballclubs.json of type JSON from the bundle. We decode it. And then once we've actually found it, assuming this works, so we didn't get an exception, we're actually going to return the decoded version of the JSON. So we now actually have an array of ball clubs as state within the view. Now, that array of ball clubs is not going to change, but it's good to get into the habit of having all the data that we display as state, so that when it gets to the point where we do want to change it, it's very straightforward to do that. We could we change this example so that ball clubs was a simple variable, but that's not the kind of thing we want to be doing in any kind of realistic app. So we'll use best practice here and actually have it as state. So now we've actually got an array of ball clubs. So what are we going to see on the screen? And we'll look at this in a bit more detail on the slides in a minute. We have a view, some subclass of view. There's a vertical stack, a label, which you can see here, and then a scroll view. So we can scroll what we're actually looking at here. The animation, by the way, the ability to stretch it and then let go, that's just part of iOS. We don't have to write any code for that. Then we have a vertical stack with a spacing between them. So how what's the word? How much space is in between each one here? If we want to change that to a 4, oops. There you go, they get close together. So we'll look at this again on the slides, but importantly, this is a live update in the preview. So we can actually see what's going on straight away. And again, contrast and compare that to how that works in Android. Decide which ones you like, and be able to have a reasoned discussion as to what are the differences between them are. And then inside the vertical stack, so we don't have a list here. We actually have a large number of text views, each one of which just has the name of the ball club. So we're ignoring all the stadiums and so on at the moment. We just want the name. And however many we put in there, we end up with a vertical stack that's inside a scroll view. So if I take the scroll view out, yeah, so we've got a vertical stack, but it's not scrollable. Then if you can see, I'm actually trying to drag it. And obviously it looks kind of nasty because it's pushing other things out of the way. So we definitely want a scroll view. But importantly, we don't make the vertical stack scrollable. There's no property to say make it scrollable. We wrap it inside a scroll view. So it's a separation of responsibilities. This is just good design in that the scroll view will scroll anything that's inside it. So for instance, if we put another one of those inside the scroll view, Let's actually just give this a different image. Oops. And there. We can tell the difference between them. That's now part of the scrollable bit. So the label doesn't know anything about it being scrolled. This vertical stack doesn't realize it's being scrolled because it's the scroll view that's doing it for us. So that's a good example. We're going to look at some of these more examples on the slides in a moment of nesting of components and using components that are very good at doing one thing. If we follow that through into our own development, we write our own components that are really good at doing one thing rather than overcomplicating it. So if we had, say, for instance, if we wanted to replace this text view with something a little bit more sophisticated, we could do that and be very, very simple change to this code here to add in that more sophisticated view of a ball club. Okay, so it's a very simple example. Obviously, just to again keep it simple, there's no tests included in that. Obviously, you would want to do that yourself. Notice that there's a deprecation warning there. This example was written some time ago. Obviously, feel free to fix that in your version of the example. All right, so that's the data classes example. So let's look a little bit more at some slightly more sophisticated parts of Swift UI. We saw a couple of them there. Let's go. So basically, what is the big deal about Swift UI? So Swift UI only works with Swift. So you can't use it if you're writing in Objective-C. There are other ways of doing that, but to a large extent, they're what's the word? Antiquated. You will still find code like that in industry because it's, if it's not broke, don't fix it. But any new code, you'll be using Swift and Swift UI. So unlike in Android, where we have our XML files that define the thing we're looking at, and we have completely separate code that defines what it does, Swift UI encompasses both of those. What the UI looks like, so how things are nested, how they relate to each other, whether or not they scroll, all that kind of good stuff, and what it does. So an example we have here, very straightforward. So this is album detail. So we have somewhere we have an album, yeah, wherever that came from. So the missing piece here, but basically it's an album, an LP, music album. And within the album, we have a collection of songs. So for every song in this album, excuse me, well, so we're going to create a list for the album, and for every song within the album, we're going to create a horizontal stack. We're going to lay things out horizontally. And inside that horizontal stack, we're going to have an image, which is a Swift UI view, which is going to be the album cover. And then we're going to have a vertical stack. So we have an image and a vertical stack. So I'll show you what this actually looks like. So here's the image. Here is the album cover. And next to it, because it's inside a horizontal stack, next to it comes a vertical stack. Alignment leading is basically saying left, justify the text that's within it. So within the vertical stack, which is this thing here, if you can see my mouse moving around that, we have the song title, and then we have the artist name beneath it in another text view with a modification to its style. So we actually use it as smaller, it's secondary. So the song title comes out bold, slightly larger text, and the artist name comes out as a slightly smaller text because it has foreground style of secondary. So quite a lot going on in that very, very simple example, and that's very much the point. Is there's virtually no code there at all, and what code there is all in one place. Yet we end up with something that's pretty nice and sophisticated. Now, how it looks, other than what we're changing here on the foreground style, we actually haven't said. Um, we said how it's laid out, but we haven't said anything about fonts or colors or anything like that. So in the same way as Android has the Material UI, Google Material design guidelines embedded in it, and we use those, iOS has a very strong opinion about how things should look. They want your apps to look like their apps. So they have a built-in style, and if we use that built-in style, our apps will look reasonably close to an app that came from Apple itself. So we want that typically, and definitely Apple want that because they've decided that that is how iOS apps should look. If you want to do something completely different, you can. We won't go into that in this class. We'll stick with the standard Apple look and feel by using SwiftUI. SwiftUI has all of that encoded in it, so we're just going to use it. But the real point here is that we have what it is we're doing. In other words, we're looping around the album and getting the information we want, and how that is laid out is done declaratively in the same place, which is in the SwiftUI code, which is just Kotlin code. Excuse me. So as we saw early on, the design tools basically once you've got the preview up, as we change it, it changes live. It's triggering off the changes that we make, and we see the version of it rendered on the right hand side. So it's a live preview. It changes as we type, but as we saw last week, in order to get the live preview, you have to stop the emulator running. It won't do both simultaneously. Typically, you'll develop with the live preview going, and then once you've got something working and you've got some tests that are proving that it works, then you would run the live application through the simulator by clicking the run button, just as a last sort of convince yourself that it really does work. But that last convincing yourself it really does work has no value beyond the 20 or 30 milliseconds it took you to do that. Only the automated tests have any long-term value or any value at all, actually. Okay, so we have views, scenes, and windows. We've seen these already. View is the main one. It represents a particular part of the user interface. So unlike activities and fragments that we had in Android, we don't need to, we can create a view which could be the whole screen we're looking at. It could be a component within it. It doesn't matter. It's just a view as far as iOS development is concerned. So we don't have to make our mind up about what is a fragment and what isn't. It's just a view. If we then say, actually, I'm going to break that down into some smaller views or combine some into a bigger one, that's fine. Everything is just a view, and it's some part of the user interface. It could be the whole screen. It could be just one little thing within it. So here's a very, very simple one. Obviously, it's just some view that has a single, contains a single built-in SwiftUI view text and say hello world. Very, very, very straightforward. Almost everything that you write in a user interface for an iOS application will be a view. But we do need a scene, and this groups different parts of your application together. As your applications get larger, we would want to break it down into multiple scenes. If we're going to have a single scene, all the views that are part of that scene are always there. But if there are parts of the application that we don't use very often, that's a waste of resources. So we break it up into multiple scenes and just use the main one all the time. And then maybe there's a preferences scene, which we only want to instantiate when on the rare occasions when someone changes their preferences. But whether it's a main scene or a secondary one, it's everything is in a hierarchy, and it's the root. So we saw in SwiftUI, you write it as a hierarchy of SwiftUI components, of views rather, and outside that, So that top level view can be in whichever scene we choose. So the most common way of representing a scene, which we've seen already in examples in our own what's the word submissions, is that we use a window group for the scene. So we've seen this already. We'll actually have a look at this, the ball clubs view and so on. And in the assignments we'll be doing for assignment 5 and assignment 6, there would be no justifiable reason for doing anything other than that. Our apps are still very simple. So it's just a single window group and away we go. And then we actually care about what's actually happening in the view that is inside the window group, which is a scene. A window group is a scene. So we'll just use that and keep it nice and simple. So for laying things out on the screen, we saw when we were actually looking at the vertical stack that we could change how far apart the individual ball club names were by changing how much space was actually between each one. So basically, stacks and spaces are the two main view or components of SwiftUI that we use to lay out pretty much anything on the screen. So these are the three stacks that we care about. Horizontal stack. So view the square and the circle are just there to demonstrate that there are different views. Don't have to be a rectangle. It doesn't have to be circular. So a horizontal stack, they appear next to each other. Yep. And the right-hand side will be squished back onto the screen that we're actually using. So there's no concept of an overflow. And then vertical stack, obviously the other way around. Obviously, if you have a vertical stack inside a horizontal stack, as we did in the little Joni Mitchell example, or you could have a horizontal stack inside a vertical stack. Either way, and to virtually any depth. We don't want to get too deep because that kind of suggests that our view is a little bit overcomplicated. But you can nest horizontal and vertical stacks within each other to your heart's content. But golden sort of keyword is keep it simple. And then we have the Z stack or Z stack, as you would probably actually call it, which allows things to notionally come out from the screen. Obviously, it's a two-dimensional device, but what it means is things lay on top of each other. So you can have a Z stack where you have components deliberately on top of each other. And again, an example, this is just straight from Apple's documentation. So here we have this little sort of card for members of staff, and we're using all three. So we have we have a Z stack which has an image in it. So that's the one that's at the back. It's the blue background, the image of this of Rachel on there. And then down at the bottom we have a horizontal stack which contains a vertical stack and, importantly, a spacer. And the spacer will expand to fit the space available. If we don't put the spacer in, then this vertical stack will expand to fit the width of the horizontal stack that it is contained in, which isn't necessarily what we want. So putting a spacer in to say basically whatever space is available to the right of this vertical stack, just fill it in with effectively nothing, rather than allowing the vertical stack to expand. So this is it in code. It's sort of it's actually shorter than that in real life, but if line returns to make it fit on the slide. So we start obviously with our profile view, and it has a body which is a view. The Z stack at the outer, and then we have the profile picture. And it's resizable, so basically it's going to fit. It's going to fit inside the Z stack, and so it will find its natural width, and the height will be set automatically because the aspect ratio has been set to fit. So it will maintain the aspect ratio. So the height of this Z stack will be determined by the aspect ratio of the image that we're using for this for Rachel. So if it needs to expand vertically, it will. And then importantly, because this is a Z-stack, on top of the image, we have a horizontal stack. And that contains a vertical stack, which has sort of the name and another piece of text for the job title. It's a subheading. So notice we're actually using slightly different terminology to set that than we did in the previous example. And importantly, on the horizontal stack, we have a spacer to the right. But if we didn't have this code down here, that vertical stack would be at the top of the Z stack. So we actually want to push it down to the bottom so it goes on the bottom edge. So this is where the padding comes in. So we're basically saying it's not quite the same as a spacer, but we're actually putting in it the whatever padding it needs to push it down to the bottom of its parent. Excuse me, and the parent in, whoops, I'm not going crazy again, the parent being the Z stack. And we can actually change the background color. So the background color is primary, which is what it would normally be. But we got a 75% opacity, so we can actually see through it to the image that's behind it. So this is a nice little bit of code. You can cut that out and play around with it and change the opacity, try and get the horizontal stack to appear at the top. So the dot padding, this means we're calling a function on this horizontal stack. Now, the padding function returns a reference to the horizontal stack, so we can daisy chain our method invocations. So horizontal stack is obviously the horizontal stack. So we call dot padding on it. That returns a reference to the stack that we just called padding on, which means we can call foreground color, which returns a reference to the horizontal stack again, and then background, which again would return a reference to it. It's just that we don't have another dot as it goes further down. So you can lay out everything. It's probably unlikely that you'll use a Z stack in any of your assignments, but you're more than welcome to. But horizontal and vertical stacks, go-tos. Okay, next sort of level up, if you like, grids. So these are views again. So we can arrange what we're seeing actually on the screen on the phone into grids, two-dimensional layout. So we have no ability in a grid to change the Z. The Z dimension. So here's an example. So we have the grid is obviously the outer one, and it contains rows. So the first row, so these are going to be vertically, one above the other. This grid row has two views, and these will be next to each other. So they're horizontal. And so we end up with this. So basically the first one, this says hello with a globe next to it. And this one has a hand wave image with the text world next to it. Excuse me. So obviously you can see that you could change that so that you can change it around so that the what's the word? One row could be above the other, but you could also recreate that using horizontal and vertical stacks. So you don't have to use grids, you don't have to use stacks. You use whatever you like to use, and will actually do the job that you're trying to achieve. So if you make that sort of slightly slightly more interesting by adding in the divider. So one of the things to notice about this example is that this is all left justified. So if you have a fairly wide iPhone screen, this is all going to be bunched up over at the left. But when we put the divider in, the divider is always full width of the screen. So when we put that in, that changes what the other views within the rows look like, because they get spread out to the full width of the screen because we put the divider in. Yeah, so dividers are fairly powerful. So for instance, if you had one of these grid row, a grid and a grid row, which you wanted to stay at the top of the screen, you could have a divider to divide it from the main content. Excuse me. Yeah, so it's the divider that actually gives us that quite dramatically changes what we see on the screen. So that is the divider there, that thin line. So in terms of actually laying things out using either grids or horizontal and vertical stacks, potentially third dimension Z stacks as well, we can now lay things out quite easily on the screen. But we also want to have some sophistication in the things that we actually view. So card views, it's not that there is no SwiftUI class for this, but cards are a well-known pattern. We use them what's the word, everywhere, in all languages and all development environments. So basically, if we got a ball club and we actually want to view it and make it a little bit more attractive than just the name from the data example we were looking at earlier on, we can declare our own view, called ball club view, which is a view, and it is going to display a single ball club. Now, one of the things to watch out for which is an interesting and slightly unusual language feature, is how we set the value of this variable. I'll come back to that in a minute. So we have the body of the view, obviously it's a view, and we have a horizontal stack. So we have some text at the bottom, we have some text, which is the ball club name, and then at the top we have the logo of the club. So if the ball club logo is a URL, we want that displayed in our app, but we use an asynchronous logo so that it can be fetched in the background thread. We're looking at this in Android in a day or so ago. So we don't want the app to be stalled and stuck whilst we go and retrieve the Red Sox logo or wherever it actually is. So we use an async logo and it will do that for us in the background. When it's retrieved the image, it will then render it on the screen for us. But if we want to create a ball club view, a ball club card, I beg your pardon, we pass in as a variable to a function the ball club that we actually want to give it. And now the order of these arguments to the ball club card view are the order in which they're defined just beneath the definition of the structure. So if we put in a second variable, we could pass that in as an argument to the constructor. Structs don't actually have constructors of this ball club view. So if we were to do that and we pass it in a ball club variable that happens to relate to the Red Sox, this is what we'll get. To the human eye, it will appear that the logo will appear instantaneously, but it's actually gone to the network and actually fetched it back for us. But if we want more than one argument, we can declare an explicit initializer on the card, but it's generally sort of frowned upon in that we would always pass in a single object. If we want to pass in more stuff, then we could declare a struct that is a combination of more than one other struct. It's one of these areas where it doesn't really matter which one you go for, so long as you use the same thing every time. People argue against using an initializer because some of your more simple structs don't need one. But if you have some structs that have an initializer and some that don't, that's just generally regarded as bad in terms of consistency. In the simple assignment solutions we'd be doing, there should be no need for you to have an initializer on any of your card views. If you find you're wanting to do one, maybe step back from that a little bit and see whether or not you could have done it in a simpler way. Okay, so in that very simple example we looked at just previously, we were just putting in individual text components into a horizontal, sorry, a vertical stack, and we wrapped that in a scrollable so that we could scroll the whole thing backwards and forwards. But typically, we have something a little bit more sophisticated than something just text. Um, we want to actually use a list. So if we have our ball clubs list, which we'll have a look in a moment, an example from the previous one. So we basically have an array of ball clubs. We saw how we could get that in the previous example. And then the view the ball clubs list is very simply a list where we iterate round all the ball clubs we have and create a ball club card for each one. So if we have multiple ball clubs in there, each had their their name and their logo, we would end up with something like this. And the list is very, very powerful. So this is what we want to be using in our assignments. It's you could have a class just on list views themselves. You don't need to when I say self-study, I don't mean spend the next 2 days reading up everything you could ever find about list views. Just be aware that it's a powerful component. If you find yourself saying, I'd like to be able to do that, and I'm using a list view, it will almost certainly be able to do it for you. So that's what I mean by self-study, isn't assume it can do it, and all you need to do is go and find out how. Right. So something else we want to consider is that in previews, um, if you sort of look, if you think about if we were fast forwarding a little bit to assignment 6, where we're connecting to the real API, we don't really want to be doing that in our previews because maybe the real API isn't, or the new version of it isn't necessarily available yet. We don't want to be tied into its availability, the version it's at. We want to be able to work independently of that. So our previews, our live view will actually connect to the API, but when we're previewing it in our development environment, we actually want to have some known data which we can actually view in the preview in the ID in Xcode. So we can use the concept that we actually have in Swift to add an extension to an existing type. So here we've got our ball club type, and we add an extension to ball club to give it some examples. So this is an array of two ball clubs, each of which has two stadiums, the regular season stadium and the spring training stadium. What we can do in our preview, so we saw this last week. So when we're using the app for real, it's going to get hold of the ball clubs from somewhere. And typically that's going to be going against an API eventually in assignment 6. But when we're doing a preview of the ball clubs, we can just use the examples that we've given as the extension. So in preview, this is what we'll get when we run against the live data, which we'll see on Thursday when we're using another ball club example against the live API. We obviously get all the ball clubs, but we've just got a couple of examples that will allow us just to check that what we're seeing is reasonable. Okay, so at this point, I'll just stick in another example because we'll here we go. Where are we? So this is going to be 09 navigation. Does it? Someone give me a thumbs up in the chat when you've got that. Okay, good. Alrighty. So obviously let's just unzip it, and you can either do file open or you can just double click on the project file. Either way. Okay, so there's a number of interesting things going on in here. Have a poke around as we do it on the slides, but I'll bring it across and walk around it on the Zoom share as well. Excuse me. Oops. So we're doing a number of things here. Actually, let me just go back from there. If we just look at the example. code. So here we've got our ball club, and this is where we have our extension in here. And if we actually look at the ball club list, so we're not going to look at the whole app, just the ball club list. We have a preview, so we're actually doing it here. Excuse me, and we're actually looking, so we're actually seeing the examples that we're actually getting from Ball Club. Yeah, so Stadium doesn't need an extension because we're actually using Ball Club in there. So if you look into the Ball Club list, we get some extensions there. And if you actually just want to actually look at what the Ball Club card will look like, same thing, is that we just use the first Ball Club that we find in the examples. Yeah, and with this, you can change it a little bit. We just have the text. Yeah. So it was just so that yeah. The important point of that example there is that if we have the text as a direct child of the view, the vertical stack is now redundant. So we should, if we want the ball club name, it should be inside the vertical stack, which is correct. Now, obviously, when we see a whole collection of ball club cards, they're going to be one above the other in the list, but it's not the card that determines where it sits on the screen. It's the list. So there's one of our cards, but it's been left aligned by the list, not by the card. So that's really important. That we separate those, separate that responsibility. Right. So let me just pop back to the slides. So obviously, same as we do in Android, we want to be able to navigate around. So the way we do that is what we're doing is the same. Obviously, the code is different because it's a completely different environment. So we need a navigation stack. And so this is it's a stack, it's more, in some ways, it's a bit like a Z stack in that they're stacked one on top of the other. And we see the bottom one, and then when we navigate down, another one goes on top of it. So we can no longer see the one that was underneath. When we navigate, we drill down even further, another one goes on top of that. When we navigate backwards, one gets peeled off the top and then back until we get to the root of the navigation stack. So the navigation link controls how we get around between them. Obviously, this is starting to sound familiar from how we did it in Android. The classes and so on we use are different. So here's the example from the code from the example that you're looking at. So we start with the view. So this is the ball club list. But if you want to navigate from it, so here's our title. And this is what will appear when we when we're actually on that particular level within the stack. So if we then actually drill down on one, then what we'll expect to see is we have we drill down a level. We'll see the code for this in a moment. And then the ball clubs, the back arrow here is created for us as it was in Android. We've said that this is the navigation title, so that when we drill down and move somewhere else to get back to it, this is the one we actually click on. So if we have a look at that in our little example, ball club example there again, which we can just do it in the preview. So we can actually preview this is the whole app. So the whole app is not a view, so there is no preview. But we know that the top level is the ball club list, and we're using the examples. We're not loading it from JSON. We're not getting it from the API. We're just using the examples. And then in the ball club list, we see the preview. So we drill down to a particular club. The back navigation is done for us by the navigation stack. And there we go. And we can go down to the cubs as well and come back. And obviously, if we run the app, so the preview gets paused. And let me get the this. It's firing up. Yeah. Yeah, we're using the demo data again, so it runs in exactly the same way in the in the simulator. Okay, so if you combine those two examples we looked at today, so this one is showing us how we do navigation, and the previous one is showing us how we load data from a resource, so a JSON file. If you combine those two together, then what have we got? Well, we got assignment 5, which is the equivalent of assignment 2 for Android. So same thing, we're going to have workspaces, channels, and so on and so forth. There's a Slack style data. And so the basic requirement, which we'll have a look at in a moment and show you what that does, is very, very simple. And we give you the tests. So it's not actually worth very much. So I'm just going to run up the model solution. Just give me a moment. Where are we? Okay, so we'll come back to that in a minute. Okay, so we give you the tests. Obviously, you have to pass the tests to get your 30%. And then the advanced bit, there's some additional user interface work that you need to do. Oh, sorry, thank you. Someone's telling me that I've got the, yep, good one. Okay, so yeah, so the basic requirement, I'll show you some screenshots in a minute. The Slack-like hierarchy, we navigate down and back, same as we did in assignment 2. We give you the tests. For the advanced requirement, you need to make that very simple UI somewhat more sophisticated. And importantly, you have to write your own tests. So you've got a bunch of tests already there that you can base yours on. But simultaneously, so this is all making it work, we want to make it right, is that we want 100% code coverage, so class, function, line, and branch. And this is across all your tests. So your, what's the word? Your first significant milestone is where you have all the basic tests passing and 100% code coverage, at which point you would be wise to submit to Canvas, because you know that's going to get you 60%. And then you would start working on the advanced features. But again, test-driven development. So for the advanced features, you write a test first, prove that your little app does not do that, make your app do that, make sure you've got perfect code coverage, and now maybe you're at 70%. And then you move on, and then you do a new feature. So don't write all of the advanced features and then say you're going to test it, because that never works, not least of which because you tend to end up in a situation where you can't get perfect code coverage. And you don't want to do that. You don't want to lose the 30% for stretch by gaining 2% on advanced. So we're very much encouraging good behavior, good practice in terms of writing test-driven development for these very simple apps. Okay, so the basic requirement, very simple. There's no fake login screen. We'll do a real one in assignment 6. But obviously we're going to be loading in the JSON as a resource. We've seen how to do that today. And we're going to be iterating through them to get our list of workspaces. We've obviously got navigation going on here. So that's a combination of the two examples we looked at today. We obviously select one. Here we have selected the elevator workspace. We drill down. We select the painter channel. And we get the list of messages within the channel. Select an individual message, and we drill down to the detail on that. So there are some things that need to go on here, getting the dates, for instance. But the most important thing is the navigation, drilling down from workspaces to channels. Sorry, from the list of workspaces to an individual workspace, which is a list of channels. What is a channel? A channel is a list of messages down to an individual message. And obviously, when we click the back, we come back to the top. So there's an awful lot of this is provided for you by iOS, but study the examples that we've looked at in class today, and you shouldn't have any problem with the basic tests. Again, recommendation, don't take one of the examples from today and try and do keyhole surgery on it. Take the starter code for assignment 5 and add in the bits as you need it. Yeah. And again, try and pass the early tests first. In the IDE, you can just run the first test until you pass it, and then run the second test until you pass it, and then run the first and second to make sure they still go, and so on. There's no point running the test that you know you're going to fail because you haven't written anything yet. But once you've passed the test, move on to the next one. Okay, so that's a basic thing. You get the test provided. But as we move into advanced, what we see on the screen gets a little bit more sophisticated. So we have some layout things going on here. We've obviously got a card for our workspaces now, rather than just text. We've obviously got a card for our channels. And then at different levels, we're basically saying, here we're saying how many channels are in this workspace, how many unique users have contributed messages to all the channels in that workspace, and when was the most recent contribution. Same here. So now when we're down a channel, it's how many messages are in this channel, whereas this is how many messages are in, so this is how many channels in this workspace. This is the number of unique contributors, this is elevator, contributors to this channel. So how many different people created these 5 messages. When was the most recent contribution? 5 days ago. So if you look at this to the elevator, you can see that there are 9 messages, yeah, and there are 6 contributors. So the 6 matches the 6 here, and 5 is the smaller of the two, 5 to 6. So 5 goes in here, and obviously there are 2 channels. We can see that here. So if we were looking at, for instance, something that was a channel called Waterproofr, how are your tests going to access the things that we can see on the screen? So we can get hold of Waterproofr. That's easy because it's text. And we can see the 5 and the 5 and the 22 days. But how do we tell the difference between this 5 and this 5? So you could say, are there 2 5s on the screen? But you might accidentally have a 5 here instead of a 22 days. So what we care about are the types of the thing that we can see, because the SwiftUI testing environment is very keen on types of things, and the accessibility label. So for those of you who've done any web work or taken a web application class with me, accessibility labels are they're a legal requirement. The Americans with Disabilities Act say you have to have them, so that screen reader technology or assistive technology can provide context information to a partially sighted or hard of hearing user who can't see, a partially sighted person can't see on the screen that we can see. So now testing needs this as well. So the accessibility label for that number 5 is count for Waterproofr. The accessibility label for that 5 is members active in. This is all in the spec. And obviously, and the accessibility label for this one is latest message in whatever the name of the channel was. So if it's 22 days, there's in the spec, that's easy. If it was 30 minutes ago, obviously you have to change what actually appears there. They need to say 30 mins. But the types are important. So all the numerical fields must be disabled text fields. Don't make them text, don't make them labels. They have to be disabled text fields. Otherwise, the known good advanced tests will not find the things you're looking for. So you have to write your own tests, and importantly, write them, test-driven development, write them one at a time, get it to pass your first test, write another test, get it to pass your second test, and so on. And you might choose to do staged submissions into Canvas so that you keep banking an improvement in grade. Okay, so let's just going to have a look at that, the model solution writing, so you've got an idea of what that's going to look like. Thinking about it. That's right. Right. So here, obviously, we've got the workspaces. These are obviously in a list. We can drill down onto one, onto elevator, for instance, and that's our painter. And obviously this is somewhat now in the future, so these are a little bit older since I took the screenshots. And then we can drill down to the messages, got some dates here, drill down to the individual message, and away we come back. So obviously the same, the data is slightly different, but it's the same as we had in assignment 2. There are some challenges on the advanced part about getting these cards to look suitable. But we've already seen in the navigation example we just looked at that we can extend structures and add example data. So when you're rendering one in your preview, and you don't have something that is only 20 minutes old, we can do that by adding in example data. Yeah, which raises and there's a question for it. Someone might like to suggest how we might do this. So if you have a requirement that says something needs to say not 5 days but 20 minutes, 20 mins, and there is no data that is that recent in the JSON file, how would you test that? So I'm going to leave that as an open question. Have a think about that, but only when you get there. Don't, squirrel that question away, but only address it once you have a test that proves your component does not render the 20 minutes correctly. It's just doing days. Yeah. How are we going to get data that is 20 minutes old into our test environment? Again, write that in and address that when you get to it. And ask questions on Slack. Go along to either Edgemails or my office hours and ask questions. And it's a very important question, but it's one that we don't prematurely optimize. We get to it when we get to it. Okay, so that about wraps us up for today. So on Thursday, we'll have a review of some of the issues we've been talking about with iOS, again, contrasting and comparing to Android. And then we'll actually look at assignment 6. Obviously, assignment 6 is the iOS equivalent of assignment 3, so against the live API. And then Tuesday, next week, we'll be into quiz 2, because next week is the penultimate week. Well, almost. After the quiz on iOS, we'll start getting into cross-platform development, and we'll be looking at the first cross-platform assignment, which is assignment 7. Okay, any questions? Are we good? I think there's one there from, who's that from? Yes, and Alan, if you want to hang around afterwards, we'll reopen the quiz for you. Okay, time break into the like there, isn't it? Yeah, right. Yeah. So, but so exactly it. So but when we but only do that when we get there. Yeah. So that's a fairly advanced feature. So if something is less than a day old, we would want to know, is it 4 hours old? Is it 20 minutes old? Is it 13 seconds old? And so on. But let's not worry about that until we actually get there. So get the basic out of the way first, perfect code coverage, get it submitted, then start working on your advanced functionality, making sure it's really, really well tested as you go. And then getting into that, how do I manipulate the data in your tests? Interesting question as you get towards the end of the assignment. Yeah. Okay. Good stuff. Okay, so yeah, so now if you want to hang around, everyone else, thanks for your time. We will see you either in office hours today or back in class on Thursday. Have a good one. Oh, and I'll post the handouts momentarily. Oh, actually, whilst you're there, let me also release assignment 4. Sorry, assignment 5, I beg your pardon, in Canvas. So those of you who have finished 4 can get on with it immediately. So July the 8th at, what time is it now? 10, open at 10:30. Okay. So someone want to Just give me a thumbs up in chat or on Zoom just to make sure you can see assignment 5 now. Yeah, Derek, you hang around as well because you missed the quiz, but so did Alan. So we'll reopen it for you. Everybody see assignment 5? Yep, good. Alrighty. So apart from Alan and Derek, thanks for your time, and we will see you later in the week.